Have you ever wanted to experience proper augmented reality? Currently, an AR headset sets you back at least $1,000, but we're determined to investigate whether a smartphone-based AR solution like this could work as an innovative head-mounted display for augmented reality that average consumers can actually afford.
But what is it that makes head-mounted smartphone AR so difficult? Well, overall it puts a huge computational load on our smartphones, and unfortunately, computational power and efficient algorithms do not allow us to create real-time systems just yet. But that does not stop us from investigating the fundamental research question. What is the subjective quality of experience when viewing stereoscopic content that is generated with the help of view synthesis for an optimal interpupillary distance? And how does it compare to content that is generated with a limited interpupillary distance from a dual rear camera smartphone? 4 video conditions with different levels of stereoscopic manipulation were generated to investigate this. A reference video by placing 2 Samsung S9 smartphones next to each other, raw footage from a Huawei P30 Pro smartphone, which has 2 cameras placed next to each other. The primary P30 lens was used as input for 2 novel view synthesis frameworks that warp to imitate the angular differences of human vision. But making the recordings required the construction of a makeshift stereoscopic camera stand that could hold 3 phones, 2 for the reference video and 1 for generating the conditions. To prevent occlusion, the P30 was placed slightly higher, which resulted in a height difference that would be fixed by offsetting the video later. A pre-test of the 4 conditions was done with 3 participants using the simulator sickness questionnaire to prevent the bias of cybersickness. Their scores showed mild perceptible discomfort, but nothing bad enough to redesign the conditions or scenes. To evaluate the subjective perceived stereoscopic quality of the conditions, we used the sandwich test methodology developed by EBU and ITUR back in 2005. It uses an explicit and a hidden video reference to compare against experimental conditions, for which the test subjects are instructed to use an absolute continuous scale to describe the perceived quality. In practice, it works by presenting all conditions parallel to each other, allowing the user to switch between and re-rate them using sliders that appear in the display itself before proceeding to the next scene.
For realizing this concept, a custom smartphone application was created in Android Studio that was accompanied by a control module written in Python. The control module was hosted on a PC and was used to transmit control events such as rating or changing the conditions to the smartphone over the wireless local area network. The app is capable of simultaneous dual video recording and playback. Computer keyboard events were used as an interface for the moderators to start a test and for the test subjects to rate, switch, and pause the conditions. As for the novel view synthesis, 2 frameworks were used that were published in 2018 and 2019 respectively. With minor modifications, we were able to use them for our purpose. Both frameworks also used 2 different approaches for solving the same problem. One extended the stereo width of 2 image pairs, and the other estimated the 3D geometry and then shifted the view using generated geometrical metadata. The results showed significant differences between the reference and dual video feeds that were rated excellent and good using mean opinion scores. Comparatively, the view synthesis frameworks rated fair and poor. The low ratings for the view synthesis frameworks may be due to the present artifacts such as visual noise and interframe instabilities. We believe that this was caused by view synthesis being done on an image-to-image basis without additional contextual metadata about the movement. Despite this and other potential biases, the findings were deemed reliable and valid indications for the potential use of smartphone dual cameras as input for a head-mounted AR product in the future. Also, we advise for a greater variety of test scenes. Generation of 2 views for both eyes from a single camera input could also produce interesting results.